Welcome to Ask and Learn.
All right, so we're asked to find the temperature at which this reaction will be spontaneous. So the best way to do that is to set our equation delta G equals delta H minus T delta S to 0. So what we're going to have to do is find delta H and delta S of reaction for our reaction here. So let's start off with finding the delta H of reaction. Again, we're going to use our equation of products minus reactants, and I always like to write out a little skeleton here so I don't get confused. So we're going to have the delta F of formation, or the delta H of formation of C2H2 plus the delta H of formation of H2 plus the delta H of formation of H2O minus, these are all our products, and then minus our reactants, the delta H of formation of CH4 and the delta H of formation of O2. Remember, when we have coefficients in our equation, we always need to put them in our products minus reactants. Oops, that is not a coefficient. Our products minus reaction equation. So we are going to put a 2 here. So 2 times the delta H of formation of H2. And then we're going to have a 2 here times 2 and times 1/2. Great. So you can find the delta H of formations most likely in the appendix of your textbook. You can also Google them. I have filled in the little skeleton here. So these values correspond to the delta H of formation of these molecules up here. Again, we're going to want to add in our coefficient. So do that again. It's always good practice. 1/2. Great. So if you want to pause the video and do that calculation really quickly, you should get a delta H of reaction of 134.914 kilojoules. And since we know we're going to put this in an equation with delta S, which is in joules, we're going to want to change our delta H into joules so that we have the same units throughout. So again, we're just going to multiply by 1,000 and we'll get 134,914 joules. Great, so we're going to do the exact same thing with our delta S reaction now. So again, I wrote out our little skeleton, and let's fill in our, I'll just do this. Our coefficients times 2 times 1/2. Great. Again, I've provided the standard entropies for all of these, but again, they should be in your textbook, or you can find them online. So fill in our coefficients times 2 times 1/2. If you want to pause the video and do that calculation really quick, you should get a standard entropy of 176.07 joules. Great, so now we are going to again use the equation above, delta G equals delta H minus T delta S. So again, we're setting delta G to 0. We're going to fill in our delta H in joules. So 134,914 joules minus X is temperature. That's what we're solving for, and 176.07 joules. Great, and that should come out to be a temperature of 775 Kelvin. So above this temperature, the reaction will be spontaneous. All right, so B asks us to find the temperature at which the formation of acetylene will be spontaneous. Again, this is from its component parts. So we're going to have C plus H2. And remember, we always have to balance our equations, never assume they're balanced. So that is just going to mean putting a 2C here. So we have 2 C's on this side 2 H's on this side, 2 C's, 2 H's. Perfect. Now we're going to do the exact same thing. Again, we're going to want to get our delta H and delta S, so we can set our delta G equals delta H minus T delta S. Sorry, that's a little messy. We're going to set delta G to 0 again. So we're going to want to find our delta H of reaction and our delta S of reaction. So let's start with our delta H. Again, it's always products minus reactants. You want to drill that into your brain. Products minus reactants. I have my little skeleton here. And again, always remember to fill in the coefficients. So again, we have a 2 there, so we're going to put it into our equation. So I have not provided the standard H of formation, or the standard enthalpy of formation, but again, you should be able to find them in your textbook. And if you want to pause the video and do that calculation, this should come out to be 227 kilojoules. And just like last time, we're going to want to change this into joules since we know that delta S is usually given in joules. So that is going to come out to be 227,000 joules. Great. And now we're going to do the same exact thing with our standard entropies. So again, remember to put our coefficients. And I haven't provided the standard entropies, but again, they should be in your textbook or you can Google them. So pause the video and do that quick calculation, and you should get 58.8 joules. All right, you know where we're going from here. We're going to plug it in to our equation up here again. So again, we're setting delta G to 0. So when you're trying to find the temperature that a reaction becomes spontaneous, you're always going to set your delta G to 0. So we have 227,000 joules on this for our delta H, and then X is going to be our temperature we're solving for, and then we have 58.8 joules over there. And then solving for X, we should get a T equals 3,855.4 Kelvin. And above this temperature, the reaction will be spontaneous. All right, so for the last question, we know that it's asking us about this initial equation up here. This is how they make acetylene in a lab, I think it says. Yes. Okay, so we know we're told that this process happens at 1500 degrees Celsius, which is about adding 273 to change this into Kelvin, 170 or 1000. Gosh, I am having a rough day. 1773 Kelvin. And from the first part of this question, we know that above 775 Kelvin, the reaction will be spontaneous. So we know that at this temperature, the reaction will be spontaneous. That means that it's just going to continue going. It doesn't need any input of energy. So we want to cool the reaction so we know that the reaction will stop. Because by cooling this down, once we get below 775 Kelvin, the reaction is no longer going to be spontaneous, so we're able to stop it.